Okay, well, it looks like we've got a good number of people who have joined us. So welcome everyone. Good morning. Welcome to the last of our 2024 CEBRA webinars, or as they've come to be known, the CEBRAnars. For those of you who don't know me, my name's Julia Wells. I'm the Assistant Secretary looking after the CEBRA relationship here at DAFF in the Biosecurity Strategy and Reform Division. Before we start, I'd just like to acknowledge the Ngunnawal people as traditional custodians of the land on which I'm meeting today, and to recognise any other people with connections to the lands of the ACT and region. I wish to acknowledge and respect their continuing culture and the contribution they make to the life of the city and this region. People don't mind going on mute. Thank you. I extend the recognition to the traditional custodians of all the other lands on which attendees are meeting from today, and to all Aboriginal and Torres Strait Islander people attending today's webinar. Knowing we're tuning in from many different places today, feel free to pop in the chat where you're joining us from. So just on housekeeping, if we can just ensure microphones are muted and your cameras are off unless you're presenting, and we are recording this CEBRAnar for those who couldn't make it today. There'll be time to ask questions after the presentation. So at that time, you can put your hand up or just post a comment or question in the chat panel and I'll help facilitate. For those of us joining for the first time, the Centre for Excellence for Biosecurity Risk Analysis, CEBRA, is a long-standing biosecurity research initiative currently hosted by the University of Melbourne. CEBRA plays a vital role in providing the Australian and New Zealand governments with expert biosecurity analysis and advice that helps inform a range of biosecurity risk management activities. Today we'll be joined by Professor Andrew Robinson, and he will be presenting on audits, how to time them to enhance the audited process cost effectively. Andrew, who's no stranger to our CEBRAnar series, is the CEO of CEBRA and part of the distinguished Chief Investigator cohort that helps drive the research undertaken as part of the CEBRA program. Andrew has a PhD in forestry and a master's in statistics from the University of Minnesota and is currently Professor in Applied Statistics at the University of Melbourne. Andrew is an elected member of the International Statistical Institute and has published an impressive collection of books, research articles, a CEBRA technical reports on various aspects of risk analysis and biosecurity. Today, we're also joined by Nick Small, Director in DAFF's Compliance and Enforcement Division, who's worked in the Approved Arrangements Program since early 2005. The Approved Arrangement Program helps develop and maintain policy for about 3,000 approved arrangements under the Biosecurity Act. Nick's been involved in a wide range of policy and operational issues for the management of approved arrangements and will provide some background to the Quantitative Model for Assurance-Based Auditing of Approved Arrangements project. So without further ado, Nick, I'll hand over to you.
Okay, thanks, Julia. Well, let's start with approved arrangements and what they are. Approved arrangements under the Biosecurity Act allow industry operators to participate in activities to manage the biosecurity risks associated with their businesses. And the types of businesses that typically enter into approved arrangements include things like sea and air freight depots, treatment providers like fumigators, research laboratories, agricultural product processors, waste disposal companies, etc., etc. There's a very long list. The department's approach to the regulation of these approved arrangements involves, firstly, setting requirements, then monitoring compliance with those requirements, and finally, responding to any non-compliance with the requirements. That second component, the monitoring of compliance, is mostly achieved through the audits that are conducted by our Audit and Assurance branch. Now, the policy on the frequency of that auditing has changed over the years, a number of times in fact, but it has always been set in a somewhat arbitrary manner. For instance, the current audit policy typically requires one audit per year. And why one audit per year? Well, it's because that seemed like a quote unquote reasonable time frame. But why not 8 months or 16 months or 4 months or 24 months? And what level of compliance risk are we accepting with our current audit frequency? And if we increase that frequency, do we reduce the compliance risk? And if so, by how much? And would the increase in compliance assurance justify the additional workload and resource demands and impost? These were just some of the questions that we started to ask ourselves probably about a year and a half ago, with a view to considering and reviewing our audit policy in a more risk-based and statistically quantified and justified way. And so it was that we approached CEBRA with with an idea for a project to look at the relationship between audit rate and compliance assurance. And powered by the enthusiasm for the dark arts of statistics, CEBRA's Andrew Robinson has produced something that we can understand, work with and apply. And personally, I found it to be a very interesting and rewarding road to follow Andrew down and watch as he took what was a messy mass of complex data and somehow shaped it into a useful model. Looking ahead to the future, we anticipate rolling the results of this project in with the results of another CEBRA project that's currently underway with the Audit and Assurance branch, in order to further evolve and strengthen the department's approach to risk-based auditing. So with all that said, I will now hand over to Andrew Robinson to tell the tale of the journey we've been on and to show you where we've arrived. Over to you, Andrew.
Thank you so much, Nick. I think I'm sharing my screen and I think my microphone is on. True?
Perfect, Andrew.
You're not sharing your screen at the moment, Andrew. It popped up and then it came back off.
What a pleasure it is to talk. Am I audible?
Yes. Yep, can hear you.
Okay.
But you're not sharing the slides anymore.
I'm not sharing the slides anymore.
We don't have a screen share.
You sure you wouldn't just rather look at my face the whole time? Okay, how about now?
Yep.
Great. Okay. Boy, this remote presentation business really exposes one's dinosauric inadequacies technology-wise. I'm going to talk about this wonderful project that Nick and I have been working on together, along with Nick Moran and Richard Whalebone, as it turns out, Nick from CEBRA and Richard from DAFF. And I'm going to confess that there's a little bit of technical detail here, and I don't like to put in too much technical detail into a CEBRAnar, but I just couldn't resist. I've tried to redact the relevant details, so we'll see how that plays, but happy to answer any questions at the end. There probably will be some details that we're going to brush over. So Nick mentioned the roles of AAs, so I don't feel obliged to read out my carefully prepared statement. But suffice to say, sorts of things that go on, fumigation of goods or containers, storage of containers, slicing up of fruit matter, that's a particularly nasty apple, and the growth of plants, amongst many other things. So the idea that underpins this model, or the idea that underpins the project, is a nagging feeling that the function of auditing a process changes the long-term compliance rate of that process. So we can imagine a process where we might never audit it, and it might go out of sync or out of spec, and we'd never know, and we'd never correct it. And then we could imagine at the other extreme, we could imagine a process that we audited every day, and every day we would only let that process run if it passed the audit. And between those two extremes, it seems reasonable to believe that there are middle points where, as we increase the time between our audits, there's more time for the process to become out of sync. When we audit again, the process flips back into sync. But as with time passes again, the audit flips back out of sync. And so it seems reasonable to believe that as a whole, all of the processes that we are auditing might reflect a level of compliance that is intimately controlled, in a sense, by how long we let pass between the audits. So following that intuitive feeling, the team wanted to be able to make a statement such as an audit rate of a certain amount, let's say 3,000 a year, 3,000 approved arrangements a year, for example, leads to a compliance level of at least, let's say, 95%, with probability, let's say 90%. So that's the kind of statement we want to be able to make. We want to be able to say, to link the audit rate to the population level compliance level, and recognize that it's going to be probabilistic. And so that's where the beautiful statistical content will come in. Okay, so of course, the department is not the only entity that does audits. So we did a bit of a dive into other entities that undertake audits against other processes. And the big ones that we found are the tax bodies, who, of course, do regular audits. Knock on wood that none of us enjoys their attention in the near future. Environmental protection bodies do audits, occupational health and safety, and public health and safety. And there's also a wide range of audits that are done by the biosecurity regulators, not just on approved arrangements. So there's lots of auditing that goes on out in the world. And we tried to find any prior art for this idea of formally linking the frequency of audits with the compliance level of the population. We didn't find anything that was particularly satisfying, but we might, to be fair, we might have missed something. Although that was Nick Moran, so I doubt that we did. So that's a bit of background. So the department gave us a beautiful data set, which had numerous interlinkages and cross-cutting sort of keys. And the things I'd like to draw our attention to are the audit criteria result table in our data set, and that had 5 million observations. So that's pretty large. And the class status data set that had 90,000 observations, and the direction status that had 400,000 observations. So we had to find a way to knit these things all together in a way that made sense, but also would be responsive to a model. And that turned out to be a very interesting challenge, which I think I'm just going to brush over pretty quickly and get to the gist of it, but we'll see. The first complication for the analysis was we needed to decide whether we... Sorry, folks, can you mute your microphones? The first complication that we had to tackle was whether we analyze the outcome of the audit or whether we analyze the outcome of the atomic part of the audit, which the various of which comprise the audit. So what I mean by that is when an approved arrangement is audited, the department takes note of all of the classes for which that approved arrangement is approved. Sometimes it's one class, but oftentimes it's more than one class. Each of these classes corresponds to a certain collection of criteria that the department then checks against as part of the audit process. So the audit could be thought of as sort of like a collection of mini audits of criteria, or an aggregation. What makes that really tricky is that the class can change in time. So an arrangement might pick up a class or it might discard a class, and non-compliances are recorded at the level of the arrangement, not at the level of the class within the arrangement. So this means that it may fail an audit for a particular class, but not other classes, and we wouldn't know necessarily which class it had failed for. So analysing the data at the audit level created this sort of discomfort around some unknowns. So we thought, well, let's look at the criterion level instead. And there were within scope, we had 1 million criteria results. And the challenge there is that the audit level fails. When an audit has a fail, it's because of the accumulation of criterion results. So what I mean by that is that, for example, 3 major non-compliances are required to end up with a fail, and those 3 major non-compliances could be across criteria that are in different classes. So that creates this confusion around the earlier point about which class records the fail. The criteria can drop in and out of the class requirement. And when a criterion is edited, then it gets a new number in the class. So we may well be looking for multiple criteria that have the same interpretation. And the outcomes could be correlated, and that correlation could vary within time. So we did try to fit a number of models to the criterion level results, and finally decided that that was not going to be fruitful. So we ended up working at the audit level. So we also had to be very precise about the nature of the records that we wanted to analyse. The department has audit outcomes recorded back for about 20 years. We decided to only include the last 10 years of audits because about 10 years ago, the department changed the way that the outcome was recorded, making it more consistent and easier to work with. So we thought we should just use those data. The audits, so we also excluded audits that didn't involve assessment of all of the conditions with which the operator is required to comply. So that means that we retained audits that are referred to as scheduled and probationary audits. We ignored audits that did not have a preceding scheduled or probationary audit because our goal was to find out what the effect of the time between audits. We did not include audits of international facilities, audits that were incomplete, and audits with null status. We also did not include customs broker approved arrangements and non-approved arrangements. That's rather clumsy, isn't it? Non-AA arrangements relating to proclaimed ports, first ports of entry, international mail centres, and food importer compliance agreements. And finally, we ignored 28 audits that were less than a week since the last audit, because we thought maybe there's something going on that doesn't reflect population level behaviour. But there were only 28 of them, so that was something like 1/1000th of the data. Okay, so having done all that, we trimmed it down to a particular number of observations that we could then analyse. And just for thinking about or reflecting the time since the last audit of the in-scope audits just for the approved arrangements that were approved at September 1, 2023, we can see that many of them have small amounts of time since the last audit, and some of them have larger amounts of time. So we have little peaks there at about 15 months, and there's a peak at 3 months, and it does go out to about 4 years, and some anomalous ones even further, which may well have been due to problems with data recording. So quite a variety of times since last in-scope audit. So now I wanted to spend a moment talking about the workflow because that's going to help clarify the material that comes next. There are 4 big steps that we're going to take now that we have settled on the level of the data we're going to analyse, and we've narrowed the scope so that we're focusing only on the audits that we really care about. The first step is to build a statistical model that will predict the outcome of an audit based on factors. And example factors for prediction are how long it's been since the approved arrangement was last audited, what the outcome of the last audit was, whether the current audit is going to be announced or not, and the classes of arrangement that the approved arrangement has. So we're trying to find a way to predict what the audit outcome will be. Then secondly, we're going to try to find a way to connect the predictions of these audit outcomes at the individual level to a prediction of population level compliance. So we're going to try to scale up the statistical model's predictions so they tell us something about the population from which the data were drawn. And then we're going to try to estimate and propagate the uncertainty about that prediction, scaled up again to the population level. This is important because we feel that there's some uncertainty in how we did the modeling that might make us unreasonably confident of the outcomes. So we worked carefully to try to capture that. And then finally wanted to develop a communication tool to assist managers to understand the outcome, and we wanted that to be transparent. And that's where we're going to wrap up. So we've got each of those 4 steps coming up. For those of you who have a very reasonable and possibly paralyzing fear of statistics, I'm going to be really light touch, but feel free to avert your eyes from the screen and breathe, take deep breaths if you feel a bit nauseous. So I've done some redaction here to keep irrelevant details out. We did this modeling that I alluded to earlier, and we tried various modeling tools. I'm gonna keep it tight here. We settled on generalized estimating equations, and for those of you who would like to talk more about why we did that and what the implications are, I would encourage you to reach out offline. We tried various ways of integrating the amount of time since the last audit. We tried it as a linear effect, and that didn't really work. And we tried it as a polynomial, and that was ugly. And then we tried it as a spline, and that was quite lovely. So we ended up using it as a spline, and quite lovely is definitely a statistical judgment. And we tried several predictive variables. So we included the time since last audit and the result of the last audit, and whether or not the audit was announced or unannounced. And also we tried the class or the classes of the arrangement that was being audited. And we found that that was really a tricky variable to work with, especially because any individual audit could be against a number of classes. And sometimes those classes would be more likely to appear with other classes. It just created an unpleasant, chaotic feel to the model that didn't give us much confidence that it was going to deliver reliable outcomes. So we dumped the class information. Okay, so now the next slide is the summary of the model. And this is let me explain what's going on here so that we can see what the model's telling us. The first thing I want to say is that the horizontal axis tells us how long it's been since the last audit. And the second thing is we're only talking about audits that are unannounced. We're not talking about, and that means that the audit team turns up. It's not an audit that they book in advance. And we thought it was important to do that because it turns out that audits that are booked in advance are less likely to fail than audits that are sort of in the moment. And that is intuitively, I guess, not very difficult to believe. The color reflects whether or not the previous audit outcome was a pass, which is green, or a fail, which is red. And the vertical axis tells us the probability that the current audit records a fail. So we can see some pretty important things here straight away. Straight away, we can see that the lines increase from left to right, which means that as the time passes, the probability that you'll detect a fail increases. And that pleasingly aligns with our earlier intuition that the more time between audits, the more likely you are to detect non-compliance. Furthermore, we can see that there's quite a difference between whether the previous audit outcome was a pass or a fail. I mean, really quite a big difference. And the final interesting point is that if you look at the green line, I noticed that there are sort of ribbons that are somewhat translucent, and those are ribbons of uncertainty. So the true lines could really be anywhere in there. Our best guess is where the solid line is, but the ribbons tell us that there's actually quite a bit of uncertainty in these data, and we really wanted to capture that. So we'll come back to that in a moment. So the other interesting thing, the thing that we found interesting, is that if you look at the green solid line at around 2 years, and you trace that that level all the way over to the left, it's about the same place as the red line at 0. So what that tells you is that the probability of seeing a fail from a audit that followed a passing audit 2 years later is the same as, really quite close to, or very similar to, seeing a fail for an audit previously failed almost immediately. So that's quite interesting. That tells us that the time effect is between, you could think of the difference between a previous audit failing and a previous audit passing as though it was a 2-year time span as well. So that provides us with a pleasing sort of intuitive record. Okay, now that's what the model outcome looks like. I'm just going to drop into the statistics really quickly for people who may be interested. And so if you don't like stats, you can sing a little song or put on some music. So this is the model summary, and what it tells us, I'm just going to give a really quick lowdown. It tells us that the duration and the audit preparation, which means is it an announced or an unannounced audit, and whether the audit previously failed are all really important in the model. And we also tested some so-called interaction effects, and these aren't important. That's the duration interacting with preparation, and duration interacting with previously failed, and these did not change. So we decided, and we did also look at preparation and previously failed, but that was very sparse. So that tells us that we're justified in being quite happy with the model that we have landed on, that I showed you in the previous slide. And the other interesting outcomes from the model are that if the audit is unannounced compared to if the audit is announced, then the odds ratio of failing is about 3.25. So it's 3.25 to 1 more likely to fail if you don't announce the audit ahead of time. And that's an interesting result from the point of view of how the regulator might choose to behave. The other interesting outcome is that if the previous audit was a fail, then the odds ratio again is about 3 to 1 that you'll fail compared to if the previous audit was a pass. And each of those is, as I observed before, about the same as a between audit effect of 2 years. So that gives us an idea of the scale of the processes that we're dealing with, and the sort of statistical and operational importance of the model, because we can detect odds of 3 to 1 by changing the way that we think about or that we carry out these regulatory activities. Okay, now coming back now from statistics to something more pleasant. We're going to go into math. Sorry, that was really a bait and switch, wasn't it? I'm now going to outline some assumptions that if we can believe in these assumptions, then we can connect those model outcomes to something very, very cool. So let's assume that every AA can either be a passing or a failing AA. And what I mean by that is if you were to do an unannounced audit today, if it's a passing AA, it'll pass, and if it's a failing AA, it'll fail. Okay, so each AA is going to be a passing or a failing AA. They start their audit cycle as a passing AA, and then they switch or don't switch to be a failing AA. And we detect that when we do another audit. So sometime before the audit, it might switch to a failing AA, and then it'll be detected at the audit time. Whether the AAs switch or not is independent, and the probability of that switching is governed by the model, which we've just looked at. Important one here, that failing AAs don't flip back to passing AAs just of their own accord. They only flip back to passing at the time of the audit, and they always do so when they're audited. And finally, the audits are carried out in such a way that all failing states are detected and non-failing states are never mistaken for failing states. So that's it's a rather burdensome reading, and I apologize for that. But these assumptions are important because what they allow us to do is they allow us to capture the audit process in what's called a two-state Markov process. This is mathematically beautiful. So remember that I said we have two states for AAs, passing and failing. We can say that the probability that it in the first audit, let's say, it passes and then moves to the second audit and passes, we're going to capture that by this P sub P of T. And the T tells us that this probability is actually a function of how long it's been since the last audit. So the converse of it, of course, is 1 minus that P sub P of T, and that's the probability that it goes to the failing state as a function of how long it is till the next audit. And then if you're a failing AA, then we know that you get audited. The probability that you are again a failing AA is going to be 1 minus PF of T, and the probability that you switch to passing is PF of T. Okay, now the reason it's great to do this, apart from the lovely mathematics, is that under very reasonable assumptions, we can then say what is the long-term probability that any AA will be a passing AA. And we can make that a function of the time between the audits. And I think hopefully you are getting an intuitive feeling that that is getting us right to the space that we want to occupy. We want to be able to say, in the long term, what's the probability that the AAs will be passing AAs as a function of how far apart we set those audits. And that's what this model can give us. And that's why it's exciting to be able to use this model. And that's why all those earlier assumptions were so important. So let's say then that pi sub pt is the probability that the AA is a passing AA. We can calculate it using this equation here, based on the fact that it is a two-state Markov process, and we can predict those two quantities directly from the model. Those are the thick lines right there that we can just read off as a function of the time since the last audit. So that brings the statistical model to the mathematical model and joins them together in such a way that it can answer the question, which is really super. The next thing is this block of text. I apologize, but it's got lots of detail. I'm just going to harvest it. The next key step, and you don't have to read this, just let me summarize it for you, is we wanted to capture that uncertainty. We wanted to capture the uncertainty that if we go back to this model here, particularly the red line, the red ribbon is quite wide. You know, for example, at 0.5 years, it goes from 0.1 all the way up to, say, 0.22. It's quite a wide variation. We want to capture that and make sure it is respected in the data, in the model outcome that we report. So we did that by using a statistical device called a bootstrap, a non-parametric bootstrap. And that sequence of steps you see there from 1 to 5 is simply an explanation of how we did it. But I don't want to go into those step by step because that's not what's important. What I want to mark here is that we worried about the uncertainty and we found a way to capture it and to reflect it in the results. And people who are interested in further detail, read the slide and or talk to us offline. And finally, we brought that all together into a graphic that communicates the outcomes. Now, there's a lot going on here, so I'm going to break this down for you. Firstly, the horizontal axis, there are two horizontal axes. The first one tells us the average time between audits in the number of months, and the upper horizontal axis is the corresponding number of audits per year that you would need to do in order to achieve the average time between audits. So that tells you, this tells you the lower axis tells you your policy, and the upper axis tells you the implications of your policy. The vertical axis on the left-hand side, you have the minimum number of AAs passing with a given probability, and on the right-hand side, the corresponding percentage of population. Now, what I need to say is that these are all relative to the suite of AAs that in-scope AAs that we had available to us in the data set. And that turned out to be 2,850 of the AAs that were approved at the 1st of December 2023. So that's why, for example, when we look at the average time between audits of 12 months, this actually corresponds to exactly 2,850 up here. I know that's not obvious from the graph, but trust me, it does. So the last thing we have is these differently colored lines, and what they reflect is the probability of achieving the outcome. And these are called quantiles. So what we might read off here, for example, is let's take this blue line here. The blue line corresponds to a 0.95. And the horizontal axis is 9 months between audits, and the vertical axis tells us 2,700. So what that says is the model predicts, with all of the uncertainties included, that if we had an average time between audits of 9 months, then with 95% probability, 2,700 of the approved arrangements would be compliant. And so that exactly answers the motivating question. And that corresponds, if we go across to the second vertical axis here, that corresponds to something like, it's not quite 95%, it's probably 94.7 or something percent of the approved arrangements in the in-scope population. So we can say that at least 94.7% will be compliant with an average time between audits of 9 months with 95% probability. So these, we can read off the different quantiles. I'll stick with the 95% because that's an old favorite. Notice that if we were to drop down to 15 months between audits, then we would be able to say that at least 2,650 of the approved arrangements would be compliant with 95% probability. And this corresponds to pretty close to 93% of the population. Now, it's very material. The very material observation is that the population is highly compliant as a rule. The compliance rate is very good. And we can read directly off what the implications would be of changing the average time between audits. And so that really is the outcome of the output of the project, is this graph that Nick and his stakeholders can use to decide on what an ideal number of audits, time between audits would be, and consequently how many audits would be needed per year. So what are the implications? Again, considering that those 2,850 in-scope audits, we've got 95% probability that at least 2,575 would pass if the audits were every 24 months, and it increases to 100 if the audits are every 12 months. It increases by 100, sorry, to at least 2,675 if the audits were every 12 months, and an audit rate of about 3,000 per year leads to a compliance level of at least 94% with probability 0.9. The current, I'll just jump back to the previous slide now, the realized average audit return period is about 18 months right now. So that's this line. So this is the kind of performance that the department is getting with the current settings. And I think, there are some intriguing questions that we could place to the project. So firstly, the way we did the model presumed that the audit return time would be set as being the same regardless of what the previous audit outcome was. And firstly, that's not how it works in practice, actually. And secondly, it seems that we could possibly get greater efficiencies in terms of the influence on the audited process by auditing the AAs that had a previous fail more frequently than the AAs that have a previous pass. And that even might create an incentive, which is a big plus for us. But the question would be how much earlier? How much earlier could we do that process of auditing to achieve some kind of balance? And obviously, you would want to be quite fastidious about monitoring this process using the technology that we've developed here. And the other interesting question is, you might remember that I said we have an assumption that the audits always detect and rectify non-compliance, and that's a reasonable assumption. But if we come back to the model here suggests that even at time 0 since last audits, there's a non-zero chance that a new audit would detect a fail. There's a couple of potential explanations for that, including that the model is wrong. But another possibility is that the audits aren't perfect, and that it may have implications in the outcome if we were to allow for that formally in the modeling process. And that brings me to the end of the presentation, and I just want to gratefully acknowledge the wonderful support from Richard, who definitely has an H in his first name, and the rest of the DAFF team. So thank you very much.
Thank you so much, Andrew and Nick, for that engaging run through of your work. I appreciate that you've recognised the importance of serious statistics, but you've also communicated it in a way that reaches a wider audience, including myself. And it's also reassuring to know that some of the intuitive outcomes, such as the difference between announced and unannounced audits, are backed by statistics. So thank you. So I'll now open to questions for Andrew and Nick. Please put your hand up in Teams or pop them in the chat.
Yeah.
Okay, Anita?
Thanks, Julia. So Andrew and Nick, just a quick question. I see that what you've looked at really is the probability of finding the critical or the cumulative major non-conformances in calculating the time frame. But Nick, I think if you're looking for an ideal cycle, at what point do you take into account things like your annual fees and your costing model so that it's easily understood by the customer in terms of saying it's a business cost to be an accredited arrangement?
Nick, you're muted.
So combining compliance results with costs, are you saying?
Well, I know that at the state level, here, and we're here in WA, so we run our accreditation scheme as well with ICA and approved arrangements. We've got an annual fee in terms of being accredited or a registered premise, and there seems to be a very good understanding from the business of what the package deal is, so to speak. Now, some of the ICA accreditations are seasonal arrangements for things like the, hard green condition of avocados and things like that, but particularly for the approved arrangements, which are premises, treatment, transport, premises, receiving premises, they are paying an annual fee for that. And so there's an expectation with that there is an annual audit, and they're aware that we can do an unannounced audit at any time if we have concerns, or if we have a detection of something that might possibly be associated with their location. But is that something that has come into your thinking as well, to say, look, this is for other administrative purposes, this is really an annual model that we're dealing with in terms of how people respond?
Look, I mean, I guess, through the course of this project, we've been very open to making it other than an annual model, although our charging is an annual model. But for the moment, charging and compliance performance are really quite separate, other than where there's been less than stellar compliance and the rate of auditing increases. So yeah, it's, I mean, I guess, there are you could potentially have other options, such as basing fees and charges on compliance performance, which in a way that happens already, because with poor compliance performance comes a greater number of those compliance verification activities. So costs inevitably go up, and that does serve as a disincentive to people for non-compliance. But yeah, look, I'm not sure if I've really answered your question there.
I guess what I'm really wondering is if you've had a look on the social side, I guess, in terms of whether you'd be likely to get pushback and actually lose some of the approved arrangements and the assets that they are for the program by having a more frequent than annual audit, and people going, well, that's just, it's not worth it to us.
Yeah, definitely. Yeah, I mean, if we went to, I don't know, let's say 8 audits a year or something, I think we would see a reasonable degree of attrition. Yeah. And in terms of modelling what that attrition would look like, that'd be very dependent, I think, on the class of approved arrangement. Like the larger operators would maybe less likely to go, but a lot of small operators would look at, say, 8 audits a year and say, yeah, we can't afford that. Makes the business non-viable. But yeah, that's not something we've looked at to date.
Thanks, Anita. Just checking if there are any other questions, if people would like to pop their hands up or pop any questions in the chat. So maybe we could ask...
Too much statistics.
Too much statistics. People... maybe, Nick, are there any particular things you're thinking of in terms of implementing this knowledge and the timing? Any next steps there?
Yeah, really looking ahead to see what comes out of the audit and assurance branch CEBRA project. So theirs has a different skew than ours. Ours is, and Andrew alluded to it earlier, it's really a really sort of population-based analysis, whereas my understanding of the CEBRA project that's being done with the audit and assurance branch is that it's very much looking at quantifying triggers for audits, like is it BMSB season, or have we had a lot of Capra beetle detected on some kind of container from some country, and so it'll be interesting to see the results. But I'm sort of at this very early stage, and not having seen the results, thinking that the work in this current project might form a bit of a baseline, and then the work that comes out of the Audit and Assurance Branch CEBRA project, that will provide some almost tactical fine-tunings to the base model for auditing in order to better address some of those seasonal triggers or compliance triggers.
Yeah, that'll be very interesting to see. So last call for any questions, or if Andrew or Nick, you wanted to say anything before we wrap up.
No, I'd like to say I also really appreciated lengthy conversations with the MPI folks early on in the project. They've been also looking at similar styles of questions and haven't come to the same place that we have at currently. They've been experimenting throughout the year with this kind of thing, but they were really great and very supportive about this project.
It's great to hear the connections here we're talking about with New Zealand, and we've had comments today from WA. So it just goes to show that the CEBRA work's really facilitating those kind of connections. So with that, I'll just thank you all for attending today's CEBRAnar. The recording will be sent out to everybody in due course, and you can also see the recordings from the previous CEBRA seminars by heading to the CEBRA YouTube channel. The 2025 CEBRAnar series will kick off early next year. So we thank you all for your continued support in sharing the research that CEBRA undertakes to inform the department's efforts to manage biosecurity risk effectively. The best way to hear about upcoming CEBRAnars is to follow us through our page on Humanitics. So once again, thanks everybody. Stay safe over the holiday season. Bye.